All right, let's talk about the growing pains of one of AI's absolute favorite tools, the vector database. It's the secret sauce behind a ton of the AI you use every day, but it's got a really big fundamental flaw. So, what's actually going wrong, and more importantly, what's coming next?
This is really the heart of the problem. The main way we give LLMs knowledge about the world, something called RAG, uses vector search. And look, it's great at finding things that are similar in meaning, but when you need it to understand how things are explicitly related, that's where it completely falls apart, and your LLM just can't connect the dots.
So, to really get to the bottom of this, we're going to frame this whole thing around two classic tech personalities you've probably met. On one side, you've got the enthusiast. They are all in on the new shiny thing, always talking about its potential. And on the other side, the seasoned architect, who's always hitting the brakes and asking, yeah, but what's the real cost? What's the complexity here? Let's see what they have to say.
Okay, our enthusiast is kicking things off, and they're basically arguing that the thing we're all using right now, vector-based RAG, is already hitting a wall.
And you can see why. The enthusiast points to analysis just like this. The real issue here isn't just about finding a document that feels related. It's about something called multi-hop reasoning. The ability to follow a chain of command or a sequence of events across different people and ideas to get to a real answer. Vectors just can't do that. And now the architect steps in to explain why it fails. In a normal vector system, all your documents get chopped up into little pieces, turned into numbers, and then stored. When you ask a question, the system just finds the chunks that are mathematically close to your query. Yeah, it's fast, but what you end up with is this, just a fuzzy cloud of disconnected information. All the real context, all the explicit links between data points, they're gone.
So, if vectors are just a messy cloud of dots, what's the alternative? Well, our enthusiast is pretty excited about this. They're here to introduce the solution that's getting a ton of buzz, especially since Microsoft Research put its weight behind it, GraphRAG.
And the difference is just night and day. Instead of that fuzzy cloud, GraphRAG builds you a structured web. Your information becomes a knowledge graph. You have nodes, which are your key entities, a person, a company, a project, and then you have edges, which are the explicit relationships between them, like works for or is the CEO of. It's not a cloud, it's an actual map of your knowledge.
That all sounds great in theory, right? But let's make it real. We're going to walk through a super practical example to show you the actual real-world difference between just finding dots and following a web.
So the enthusiast throws out a pretty common business question. Answering this isn't about finding one document. The system has to connect three totally separate things: a person, Jane Smith, a company, Acme, and a specific project.
And here's our architect pointing out what you get back from a vector search. It finds all the right keywords, sure, but the results are completely disconnected. Is Jane Smith the project manager for these projects? Is she even in that division? The system has no idea. It just throws a list of facts at you and forces you, or the LLM, to guess. And guessing is how you get things wrong. Then the enthusiast shows us how GraphRAG does it. And wow, just look at this. It doesn't guess. It follows a path. It finds the Jane Smith node, then it follows the works for relationship right to the Acme node. From there, it follows the leads relationship directly to the project. The answer is precise, it's accurate, and you can trace every single step.
So let's just boil this down. This is the core difference right here. Vector RAG is all about similarity. It finds things that are mathematically close, that kind of feel alike. GraphRAG is all about relationships. It follows a defined, explicit path between things you already know are connected.
And that difference in approach, it leads to some massive benefits. The enthusiast is quick to jump on this, saying, look, this isn't just some cool academic idea. It has a real, measurable impact on how accurate our AI is. And, this is the big one, on whether we can actually trust its answers.
For those complex questions, the ones that require connecting multiple dots, the performance boost is just huge. I mean, we're seeing benchmarks showing accuracy gains of up to 35% when you switch to a graph-based approach. That is a massive leap in how reliable these systems are. But hold on, our architect brings up the elephant in the room: hallucinations. As this paper points out, even with RAG, LLMs are famous for just making stuff up. And that's not just annoying, it's genuinely dangerous in fields like medicine or law where a wrong answer can have serious consequences.
And this is where our enthusiast says GraphRAG really shines. It's not just about getting a better answer, it's about being able to prove why that answer is correct.
Because you can actually trace the path through the graph, the system's reasoning is totally transparent. It becomes faithful, stable, consistent, and you can follow the breadcrumbs all the way from the question to the answer.
The architect has been listening patiently, but now it's time for a reality check. You can almost hear them saying, okay, this sounds amazing, but what's the catch? What is this going to cost us? It's time to talk about the real-world challenges of actually building this thing.
And here they are, the architect's biggest worries. First, you don't just get a knowledge graph for free. You often have to use expensive, powerful LLMs just to build it in the first place. Second, following all those connections in a graph can be a lot slower than just looking up a vector. That means higher latency. And finally, it's a constant headache. Every time new information comes in, that graph needs to be updated, and that's a real operational burden. So, what this all boils down to is a classic engineering trade-off. There's no free lunch here. On one hand, you have the speed and simplicity of vector-arg. On the other, you have the precision and explainability of GraphRAG. And there's no single best answer. It all comes down to what your specific project really needs. So after all that back and forth, where do we land? Our two tech leads are coming together to give us a final summary and a recommendation for when you should be using each of these powerful tools.
And this table really lays it all out, doesn't it? VectorRAG, fast, simple, and it's your go-to for general document search. But its big weakness is that it can't connect the dots. GraphRAG, on the other hand, is the star player when it comes to accuracy and complex questions, but it's going to cost you more in time and resources. It's the perfect fit for areas where relationships are everything. Think supply chains, fraud detection, or deep legal research.
But the enthusiast has one last idea. Maybe the future isn't about choosing one over the other. Maybe it's about using them together. Imagine this. You use a fast vector search to find a bunch of potentially relevant documents, and then you unleash a knowledge graph to deeply analyze the relationships just within that smaller set of results. You could get the best of both worlds, the speed of vectors and the precision of graphs.
But our architect gets the last word, and it's a word of caution. As powerful as GraphRAG is, the sheer overhead of building and maintaining that knowledge graph means that right now, it's really best for big enterprise-level projects. Places where the high cost is totally justified because you need that extreme accuracy. For most smaller, medium-sized businesses, it's probably not your default choice. At least, not yet.
And that brings us to the final question, the one you should be asking yourself. This whole debate really forces you to look at your own data in a new way. When you think about your organization's knowledge, what do you see? Is it a fuzzy cloud of similar ideas, or is it a tightly interconnected web of relationships? Your answer to that question is going to define the future of your AI strategy. Thanks for joining me.